In this video, we're going to talk about solving exponential equations. Now, in the previous video, we solved exponential equations using this fact. The fact that if a to the u is equal to a to the v, then u is equal to v. But this fact only applies in certain situations. Now, one situation where it would apply would be a situation like this. If you wanted to solve 5 to the x minus 4 is equal to 125. Now, notice in order to apply this fact, we have to have the same base, a, on both sides, but we don't here. We have 5 and 125. But we kind of lucked out because 125 is the same thing as 5 cubed. Okay, if this were 126 or 137 like we have in part A, then we couldn't do this because 126 or 137, that's not 5 to some nice power. It's not 5 to the third or 5 to the fourth, but 125 works well. It's 5 cubed. And so what we can say now is that x minus 4 has to equal 3. Okay, that's what that fact tells us. And so x is equal to 7. Okay, but if we change this a little bit, we have 5 to the x minus 4 equals 137. How do we solve a problem like this? Well, it turns out we're going to use logarithms. Okay, in fact, the whole point of us learning all those rules and properties of logarithms was so that we could solve equations like this. Okay, and what we're going to do is take a logarithm of both sides. Now, you have a choice. You could use natural log of both sides, or you could do log base 10 of both sides, and those are good choices because your calculator has those two buttons, natural log and log base 10. Another good choice for this would be log base 5. Take log base 5 of both sides, and the reason 5 works well is because 5 is the base here. But really, you can take log base whatever you want of both sides. Let's just do natural log of both sides. Natural log of 5 to the x minus 4 is equal to natural log of 137. Okay, now we can use the power property of logarithms to bring this x minus 4 out front. And what we have is that x minus 4 times natural log of 5 is equal to natural log of 137. And so we want to solve this for x. We have x minus 4 times natural log of 5. So to get rid of that natural log of 5, we will now divide both sides by it. And we end up with x minus 4 is equal to natural log of 137 over natural log of 5. If we add 4 to both sides, what we end up with is x equals natural log of 137 over natural log of 5 plus 4. Okay, now you could plug this into a calculator and figure out what it is as a decimal, and then go back up here and check your answer by plugging it in. In fact, I did use a calculator, and I found that this was equal to 7.0569560 ... Okay, some crazy decimal. Now, another way to solve this above problem would have been to take log base 5 of both sides. In fact, let's do that. Let's take log base 5 of both sides and see what happens. If we take log base 5 of the left side and log base 5 of the right side, the reason this is nice is because the left side is going to simplify to just x minus 4. Okay, one way to see that is you could bring the x minus 4 out front and you'd have x minus 4 times log base 5 of 5, but log base 5 of 5 is just 1. So what we have is x minus 4 is equal to log base 5 of 137. Okay, that left side just simplifies to x minus 4. Now add 4 to both sides and we get x is equal to log base 5 of 137 plus 4. Okay, so that's our solution. Now you might wonder, shouldn't our solutions be the same? The first time we solved it, we got this as our solution. The next time we solved it, we got this as our solution. And they look different, but actually they're the same. In fact, if you use the change of base formula with log base 5 of 137, you can see it's the same thing as natural log of 137 over natural log of 5. Okay, in fact, that's what you do. If you're trying to figure out what this right-hand side is as a decimal, you would rewrite this as natural log of 137 over natural log of 5. Okay, or log base 10 of 137 over log base 10 of 5. And then add 4 and you get your answer. You'd see that it's the same answer, the same decimal here. Okay, now in the next problem, this is slightly simpler. We just have 3 to the x is equal to 10. Now it's sometimes a good idea to kind of guess what your answer is going to be. Now notice that if we plugged in 2 for x, the left-hand side would only be 9. But if we plugged in 3 for x, the left-hand side would be 27. It'd be too big. So I'm guessing, in fact I know, that the x here has to be a little bit bigger than 2. Okay, less than 3 definitely, but just a little bit bigger than 2. How can we find out what it is exactly? Well, let's take a logarithm of both sides. In fact, let's take natural log of both sides. Get natural log of 3 to the x equals natural log of 10. Again, use the power property to bring the x out front. And we have x times ln of 3. If we want to get x all by itself, we'll have to divide by ln of 3. And we get the solution x equals natural log of 10 over natural log of 3. That's our solution, and I plugged this into a calculator and I got 2.095903. Okay, and there's this decimal that just keeps going on and on forever. But notice it is just a little bit bigger than 2, like we expected. And you could check your answer by doing 3 to this power and see if it equals 10. Now, since we rounded this off a little bit, maybe 3 to that, if you just plugged in this, would end up being 9.999 or 10.0001. But this is the decimal approximation of the answer. Okay, now in part C, we have 5 to the times e to the x squared is equal to 400. We want to get rid of the 5 on the left side, so we divide by 5. We're multiplying by 5, so we divide by 5 to get rid of it. And we have e to the x squared is equal to 80. 400 divided by 5 is 80. Okay, now we take a natural log of both sides. And actually, the left-hand side is just going to simplify to x squared. One way to see that is bring the x squared out front and multiply by ln of e. But actually, ln of e is just 1. Okay, so we have x squared is equal to natural log of 80. And so x is equal to plus or minus the square root of natural log of 80. Okay, take the square root of both sides, or really plus or minus the square root of both sides, and that gives you the answer. And again, you could figure out what natural log of 80 is as a decimal, and then take the square root and then plug in both the positive of that and the negative of that into the x, and they should both be solutions. All right, now the last problem here I think is the hardest problem. Notice that we cannot just set x equal to x plus 10. And the reason is because we don't have the same base here. We have 3 as the base here, 2 is the base here. So how do we solve this? Well, again, we're going to take a natural log of both sides. Natural log of 3 to the x equals natural log of 2 to the x plus 10. And again, use the power property of logarithms to rewrite the left-hand side and the right-hand side. And now how do we solve this? Well, notice natural log of 3 is really just a number. It's just some crazy decimal. We have x times this decimal is equal to x plus 5 times this decimal. Okay, the way to solve this, the first step we're going to do is to distribute the ln of 2. Okay, so rewrite the right-hand side as x times ln of 2 plus 10 times ln of 2. Okay, now notice we have two terms that have an x in them. Okay, one on the left side and one on the right side. Let's get them both on the same side of the equation. So let's subtract this term from both sides. And notice that on the left side we'd have x times ln of 3 minus x times ln of 2. And on the right side we'd have 10 times ln of 2. Okay, so both of the terms on the left side have an x, and so we can factor it out. That was the whole point of getting those terms on the same side, so that we can now factor this out. We can write this as x times ln of 3 minus ln of 2. Okay, now we have x times something equals something. The way to solve that is to just divide by natural log of 3 minus natural log of 2. You can think of this as like it's in parentheses here, so you can factor these. And do the same thing to the right-hand side. And what we end up with is x is equal to 10 times ln of 2 divided by ln of 3 minus ln of 2. Okay, again, you could figure out what this is as a decimal using a calculator. I would be a little bit careful about using parentheses when you use a calculator, but this turns out really is the correct solution.